All right, today we're going to go on a journey deep, deep beneath our feet. We're not talking about the crust we walk on or the super hot core at the very center, no. We're talking about that huge, mysterious layer that's sandwiched right in between. That's right, the Earth's mantle. So let's dive in.
So take a look at this. It's a fantastic cross-section of our planet. You see that super thin layer on the outside? That's the crust. That's where we live. But right below it, that's the main event. That enormous layer is the mantle. It's basically the engine that drives our entire world. And you know what? It's a place we've never actually seen with our own eyes. So let's explore it together, shall we? One layer at a time.
Okay, first things first. We really need to get a handle on just how massive the mantle is. It's kind of hard to imagine, but the numbers here, well, they're pretty mind-blowing.
Get this. The mantle makes up a whopping 84% of our planet's total volume. Just let that sink in for a second. 84%. That means almost everything that makes up the Earth is actually the mantle.
And how thick is it? We're talking 2,900 kilometers, or about 1,800 miles. To put that in perspective, that's like driving from New York City all the way to Denver, but you're going straight down. It's just a gigantic part of our world.
Now here's where things get really interesting and a little weird. The mantle is solid rock, right? But over millions and millions of years, it actually flows. Scientists love this analogy. They say it has the consistency of really thick, slow-moving caramel. And this crazy dual nature, being solid but also moving, is absolutely key to understanding, well, pretty much everything about how our planet works.
All right, let's continue our journey down into the upper mantle. And what we find right away is that it's not just one solid thing. Nope, it's more like a story of two totally different layers that work together in this really remarkable way.
So the very top bit of the mantle is pretty cool and rigid. It's actually fused together with the Earth's crust, and together they form this solid outer shell we call the lithosphere. Now, this shell isn't one single piece. It's broken up, kind of like a cracked eggshell, into what we call tectonic plates. And our continents and oceans, they're just riding on top of these plates like giant puzzle pieces.
Okay, so right underneath that rigid shell, things change. We hit a much softer, hotter layer called the asthenosphere. This is that caramel layer we were talking about earlier. It's still solid rock for sure, but it's soft enough that it can flow very, very slowly. And those big rigid plates of the lithosphere, they are literally floating on top of this soft, moving layer. So let's just quickly sum that up. We've got two very distinct parts here. You have the lithosphere, that's the hard, brittle plate we're all living on. And then you have the asthenosphere, that's the soft, flowing caramel layer that it rests on. And it's this amazing setup that allows for things like continental drift.
Okay, time to go even deeper. We're leaving the upper mantle and entering a really mysterious area called the transition zone. And scientists think this place might be hiding an absolutely incredible secret. I mean, something that could completely change how we think about where all of Earth's water comes from.
I know this is going to sound like something out of a sci-fi movie, but this is a real question scientists are asking. Could there really be an entire ocean's worth of water, or maybe even more, locked away deep inside the Earth? And crazily enough, the answer seems to be yes. Now, it's not a big underground ocean of liquid water. Instead, it's trapped inside the crystal structure of the rocks themselves. See, in this transition zone, the pressure is so intense that it changes certain minerals, like wadzolite and ringwoodite, and basically turns them into tiny little sponges that can soak up and hold on to water molecules. So this huge hidden ocean is actually stored inside solid rock. How incredible is that?
Okay, we've made it to our last stop inside the mantle itself, the lower mantle. And let me tell you, this is the biggest and most extreme place we've seen so far. We're talking unbelievable heat and pressure.
This one single layer is bigger than all the other layers above it combined. It's just this huge expanse of super hot, incredibly dense rock that stretches for thousands of kilometers all the way down toward the Earth's core.
The conditions down here are just extreme. The temperature gets up to over 7,000 degrees Fahrenheit. That's way hotter than it needs to be to melt rock. So why isn't it all liquid? Because the pressure is just off the charts. It's over 1 million times the air pressure we feel at the surface. And that incredible pressure literally squeezes the atoms so tightly together that the rock is forced to stay solid, even with all that heat.
So, okay, we've seen how huge and, frankly, how weird the mantle is. But you might be wondering,
Why does any of this matter to us, way up here on the surface? Well, it matters because this slow-moving giant is the engine. It's what drives almost all of the geology on our planet.
The whole mantle, from top to bottom, is constantly moving. It's just happening in super slow motion. You have hot rock from way down deep that rises up, and at the same time you have cooler rock from the top that sinks down. The best way to picture it, think of a giant planet-sized lava lamp. This whole process has a name: convection.
Let's break that cycle down real quick. Step 1. Rock down near the super hot core gets heated up. When it gets hot, it expands and it becomes less dense. Step 2. Because it's now lighter, it starts to slowly rise, a journey that can take millions of years. And step 3. Once it gets near the top, it cools off, gets denser again, and sinks right back down. And this simple, beautiful cycle, this is what powers our entire planet.
And believe me, that engine is responsible for a lot. These slow-moving currents are what drag our tectonic plates all over the place, which is why continents move. They build up all the stress in the crust that eventually gets released as an earthquake. And they're what create the molten rock, the magma that erupts from volcanoes. The mantle is constantly, and I mean constantly, reshaping our world from way down below.
Now, we can't exactly drill down to the mantle, right? But sometimes a little piece of it comes up to us. Take a look at this green rock. It's called peridotite. This is an actual piece of the upper mantle. It got caught up in some lava and carried all the way to the surface during a volcanic eruption. As far as we know, this is our only way to get a direct sample, to actually hold a piece of this hidden world.
So there you have it. The mantle is this incredibly dynamic world of flowing rock, hidden oceans, and mind-boggling pressures, and it's always shaping the ground right under our feet. We've peeled back a few of its secrets today, but it really makes you wonder, doesn't it? What other secrets is this giant still hiding? Maybe the answers to where life came from, or maybe even brand new kinds of matter we can't even imagine. The journey is far from over.